Okay, so part two of the review. So we're going to look at chapter 5, and here we're going to look at area and volume unit conversions. So in part 1, we looked at doing unit conversions with just one dimension, so we're just doing like miles to kilometers. But when we do 2 dimensions or 3 dimensions or 4 or 5 dimensions, depends on what kind of crazy math you're trying to do, we want to convert once for each of the dimensions. So with area, we got meters squared. So if we want to convert 10 meters squared to yards squared, what we want to do is we want to figure out, hey, how many units do we have? We got meters times meters. We got 2 meter units. So we want to convert both of them. So we're going to use the solution 2 from part 1 of this video where we looked at converting units with solution 2. Using a unit conversion, the unit that we have, meters, is going on the bottom. And the unit we want is going on the top. So we got 0.91 yards divided by 1 meter times 0.91 yards divided by 1 meter. And here I got 1 and 2 just to signify that I'm canceling out my first meters and then cancel out my second meters from my second meters here. So now this gives me, can I cancel my meter units out? 10 times 0.91 yards times 0.91 yards. So I got the unit conversion twice because I got 2 sets of meters. And that's going to give me 8.3 yards squared. Now for 3D, I have 3 units. I have 3-dimensional. So I got centimeters cubed so let's convert 10 centimeters cubed into meters cubed. So we got a unit conversion between 1 meter and 100 centimeters. And the unit we have is going to go on the bottom. So the ratio we're going to use here is 1 meter divided by 100 centimeters. And we want to do this 3 times because we have 3 sets of centimeter units. So I put it all together. I just took everything on the top and multiplied together, and everything on the bottom I multiplied together. So I just kind of reduced this to be one fraction. If you don't like this way, you don't have to do this way. You can do the same way that we did for the area one, where you just cross them out in the first place. But here, so we got 10 times centimeter times centimeter times centimeter, and those 3 centimeters are going to cancel out with the 3 centimeters on the bottom, and we're left with our units of meters, 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 so meters cubed, and we're going to divide by 10 divided by 100 times 100 times 100, so that's going to be 10 divided by 100 to the power of 3, which is going to be, if I'm right, 100,000. Yeah, nope, a million, 1 million. So we got 10 meters cubed divided by 1 million, and that's going to give us 1/100,000, so 1.00001 meters cubed. So because we have to convert 3 times, if you take 10 centimeters cubed, that's nowhere even close to being 1 meter cubed. It's such a smaller value. But if you take 10 centimeters, well, that's only 1/10 of a meter. So by doing the unit conversion multiple times, or because you have to do it multiple times for volume, you can get much smaller numbers for the volume, or you can get much bigger numbers if you convert it to a small unit. So if you convert it to millimeters, it'd be a really big number. So the difference between units is bigger when you go into more dimensions. So remember this. This also shows up in one of the problems in the last problem set. So looking at chapter 6, here we finally get away from measurements and unit conversions, kind of. And we're going to look at unit price, best deals, and discounts and increases. So kind of a bunch in one go. So looking at unit price. So I picked an example here to hopefully help you with the second question in the problem set. So if you're not too sure what to do, please use this as an example. So with the unit price, what we're going to do is we're going to try to have the price per set amount. So if you go to the grocery store and you go to get like sliced meat, it's going to be like, oh, here's the price per 100 grams. So generally the price would be like per 100 grams, per pound for produce, or per kilogram, depends where you shop. So in this problem here, we have a sheet of gold paper, and it's going to cost $100 for this sheet of gold paper. It's real expensive for some reason. And the piece of paper is 8 inches by 11 inches. And we want to figure out what the cost is per square inch. Okay, well first, let's figure out how many square inches do we get in this piece of paper. So the piece of paper is 8 inches by 11 inches. So the area is going to be 8 inches times 11 inches, so the length times the width. giving us 88 inches. So then our unit price is going to be the cost divided by the amount. Now this is going to be $100 divided by 88 inches squared, or squared inches. And that's going to give us our 1.14, so $1.14 per square inch. So what we're doing here is we're taking our $100 and we're dividing it by 88, and we're leaving the unit on the bottom. And that's going to give us a price per one of the units, so per square inch. Now, so unit price is going to be the cost divided by the amount, and depends on what you're trying to find. Two other useful equations to have is that the cost is going to be, so how much it's going to cost you to meet unit price times the amount. So if you get, say it's $2 for 100 grams of sliced ham, and you want to get 200 grams, well, it's going to cost you, and your unit price is per 100 grams, so you're going to double that, so your amount would be 2. So it would be your unit price times 2, so it costs you $4. And then the other one is the amount. So let's say you have $10 and you want to figure out how much ham you can get. Well, the amount you can get is going to be the cost divided by the unit price. And that will give you the amount that you get. So when you're trying to find the best deal or the cheapest deal, well, mainly really the cheapest deal, because when you're trying to find the best deal, there's other things to consider. But the cheapest deal, all you really want to do is you find for the 2 or more objects you want to think about per, you find the same unit price, so the price per same unit, and you want to figure out which one has the lowest price. So whatever has the lowest price per unit is going to be the cheapest one. So that's a way, because sometimes you get 2 different amounts. You don't know, okay, which one's cheaper, which one's more expensive. So you can do the math to figure out which one's going to save you the most money. Okay, so looking at percent increases and decreases. So I show you 2 methods here. It's up to you which one you want to do. It's essentially the same. So let's say we have a TV, and it's regularly costs $1,000, but it's 22% off, and then there's a 12% tax on the TV. So first we want to do the discount, and then we add the tax based on that discount price. So the cost of this TV is going to be $1,000, and then we're going to take away the 12%, or sorry, the 22% of that $1,000. That's what you save. So moving 22% into decimal, that's going to be 0.22. So we're going to divide by 100 to get into decimal. And that's going to give us a total of $780. So now we want to figure out our price. So we're going to add our net price with tax. So we're going to take, okay, a base price of $780. And instead of minusing where we get a discount, because we have to pay more because of tax, we're going to have an addition. We're going to add 12% of the total cost. So 12%, which is going to be 0.12 as a decimal, again divided by 100. And that's going to give us about $875 with tax. So tax is almost $100, which is quite a bit. So I'm not too sure if the tax on TV is $12 or $5 or $7, but it can be quite a bit. All right, so let's look at a different way to do this problem. So here, instead of figuring out how much we save, we're just trying to figure out how much we have to pay, essentially. So we get the same answer in the end. We're just going to kind of do a different method. So we're going to figure, okay, if we get a 22% discount, what percent do we have to pay? So we regularly pay 100%, and we're going to minus our 22, and we only pay 78%. So now we can just do the cost is going to be our $1,000 times 78%, or 0.78 as a decimal, and that's going to give us the same cost of $78. And the taxes, okay, now we got to add 12% onto our price. So we have 100% plus 12%. So we're going to pay 100% of the cost, and then we're also going to pay 12% extra of the cost. So 112%. And as a decimal, when we divide that by 100, it's going to give us 1.12. So we're going to multiply that by our cost, as currently cost is $780. It's going to give us the same price of $873.60. Okay, and on to our last one here, chapter 1, and this is making money. So here we looked at like hourly wage and salary. So I got two people, Josh and Jack, are going to make some money in different ways, and we're going to figure out how much to make hourly and how much to make yearly. So Josh makes $24 per hour plus 4% vacation pay. So that 4% vacation pay just gets added on to his salary, to his pay every paycheck. So 4% how much he makes gets added on. And let's say he works 40 hours a week, and 46 weeks a year. He takes a solid 6 weeks off each year, which is fair, I think. As a teacher, I guess I take lots of weeks off. Um, so when we want to figure out his hourly wage, we're going to add in that 4% pay. So he gets $24 an hour plus 4% of that. So 24 plus our 4% times 24. And 4% as a decimal, we get 0.04. Because we want to divide by 100, we want to make sure that's not going to be 0.4, which would be 40%, 0.04. And that's going to give us just under $25 an hour. So that's going to be his hourly salary. Now, for Jack, who's making $67,000 a year, to find his hourly wage, it's going to be a bit trickier. So we want to figure out how much he makes per hour. So to do that, we're going to say, okay, he makes $67 per year, and each year he's going to work 50 weeks a year. So we're going to replace 1 year with 50 weeks. And then we can do the division of 67,000 divided by 50. That's going to give us $1,340 each week. So that's how much Jack makes each week, which is pretty good. So then let's figure out how much he makes per day. So he works 4 days a week. So we're going to replace the week with 4 days. Again, do the division. That's going to give us $365 per day. Not bad. And then we're going to say, okay, well, he works 10-hour days. So we're going to assume if you're in salary, you're not making bonus pay, so you don't have to worry about like, oh, he's getting 1.5 pay for 2 hours. It's not a thing when you work salary. So we're going to replace 1 day with 10 hours, do the division, and we will figure out that he's going to make $33.50 each hour. Now for yearly salary, Jack is really easy, just $67,000 per year. Now for Josh, now we got to kind of go to the backwards of what we did for Jack's hourly wage. So we're going to do a unit conversion essentially. We're going to convert from an hour to a year. So we have that the pay of adding that 4% on initially. We got $24.96 per hour. And then we're going to convert from hour to week. So 1 week equals 40 hours. So we're going to put the unit that we so what we were doing before, we were putting the unit that we have on the bottom. But because we're dividing by per hour, we want to put the unit we have on the top. So this one's a bit trickier. So because we're dividing by an hour, we want to put the unit that we have on the opposite side. So so if it's on the bottom, we want to put it on the top. If it's on the top, we want to put it on the bottom. So we're going to convert from 1 hour to 1 week. So we got 40 hours per week. And then we're going to convert from 1 week to 1 year. So we got 46 weeks per year. And once we cancel out units, we get final answer of $24.96 times 40 times 46 per 1 year. And that's going to have a salary of just under $46,000 per year. So that's your review for the course. It was pretty fast. There's definitely some stuff I missed. So hopefully that will help you finish up your final assignment. And that's kind of going to be the last lesson for this class. On Friday, I'm going to put a video just kind of wrapping things up, but there won't be any assignment or anything like that with it. So if you have any questions, please let me know. Thursday, we're also going to do our video call. And then next week, we'll have a couple video calls as well. So I'm hoping more people will join just so we can kind of have somewhat of a wrap up. Say goodbye to everybody, something like that. So have a great rest of the day, and I'll see you next time.